In May 2024, a Chinese submersible descended nearly 7 miles into the Mariana Trench, the deepest point on Earth. What they found wasn't just interesting, it was geopolitically explosive. Massive deposits of rare earth elements, enough to power billions of smartphones, electric vehicles, and military systems, sitting in international waters in one of the most hostile environments on the planet. And here's why this changes everything. China currently controls 70% of the world's rare earth supply. They've weaponized this monopoly before, cutting off exports to Japan in 2010, threatening the US during trade wars. The entire green energy transition, the entire defense industrial base of the West depends on minerals that one country controls. Until now. Because the Mariana Trench discovery doesn't just offer an alternative source, it opens a new battlefield. Not on land, not in space, but in the deepest, darkest, most unexplored territory on Earth, the ocean floor. By the end of this video, you'll understand why the next Cold War might be fought at crushing depths, why companies and nations are suddenly pouring billions into deep-sea mining technology, and why what happens 36,000 feet below the surface could determine who dominates the 21st century. This isn't science fiction, this is happening right now, and most people have no idea. The Mariana Trench is the world's deepest part of the oceans, nearly 36,000 feet at its deepest point. That's deeper than Mount Everest is tall. The pressure at the bottom is over 1,000 times atmospheric pressure at sea level. It's pitch black, near freezing, and until recently, almost completely unexplored. We've sent 12 people to the moon. Only 3 people have ever reached the bottom of the Mariana Trench. But what Chinese researchers found in 2024 wasn't at the very bottom. It was on the slopes and surrounding areas, still miles deep, but in a zone that's theoretically accessible with existing technology. They discovered polymetallic nodules. These are potato-sized rocks scattered across the ocean floor, formed over millions of years as minerals precipitate out of seawater and accumulate around a nucleus like a shark tooth or shell fragment. And inside these nodules, a treasure trove of rare earth elements: neodymium, praseodymium, dysprosium, terbium, names that mean nothing to most people but are absolutely critical to modern technology. Neodymium is essential for the powerful magnets in electric vehicle motors and wind turbines. Dysprosium makes those magnets work at high temperatures. Praseodymium is used in aircraft engines. Terbium goes into solid-state lighting and displays. Without rare earths, there are no iPhones, no electric cars, no wind farms, no F-35 fighter jets, no precision-guided missiles. And right now, China produces about 70% of the world's rare earths and refines over 90%. They don't just mine these elements, they control the entire supply chain. This has been a strategic vulnerability for the West for decades, but every attempt to break China's monopoly has failed. Rare earth mining is expensive, environmentally destructive, and the refining process is chemically complex. China cornered the market by being willing to accept the environmental costs and by subsidizing production for decades. Until someone found a deposit so large and so concentrated that it might actually be worth the insane cost of retrieving it from the ocean floor. The initial estimates suggest the Mariana Trench region could contain rare earth deposits worth trillions of dollars, enough to supply global demand for decades. But there's a problem. Several problems, actually. Problem number 1. Who owns the ocean floor? The Mariana Trench sits in international waters beyond any nation's exclusive economic zone. Technically, it belongs to no one. Legally, it's governed by something called the International Seabed Authority, a UN body created by the Law of the Sea Convention in 1982. Here's how it's supposed to work. Any nation or company that wants to mine the deep seabed has to get approval from the ISA. They have to follow environmental regulations, and they have to share the profits with developing nations through something called the Common Heritage of Mankind principle. Sounds reasonable, except the ISA has never actually approved a single commercial deep-sea mining operation. The regulations are vague, the environmental standards are unclear, and the whole system is designed for a world where deep-sea mining wasn't actually possible. Now it is, and the legal framework is completely unprepared. China is playing a careful game. They haven't claimed ownership of the Mariana Trench deposits. Instead, they're investing heavily in the technology to extract them, positioning themselves to be the first to commercially mine the deep ocean, just like they were first to corner the rare earth market on land. But other players are scrambling to catch up. The United States has suddenly become very interested in deep-sea mining. So has Japan, which has almost no land-based rare earth deposits and is terrified of Chinese supply cutoffs. South Korea, European nations, even private companies are getting involved. A Canadian company called the Metals Company is developing mining equipment for the Clarion-Clipperton Zone in the Pacific, a region estimated to contain more nickel, cobalt, and manganese than all land-based reserves combined. Lockheed Martin, yes, the defense contractor, has been researching deep-sea mining technology for years. And here's where it gets geopolitically messy. The United States hasn't even ratified the Law of the Sea Convention, which means technically the U.S. isn't bound by ISA regulations, which means if an American company wants to mine the Mariana Trench, there's no clear legal framework to stop them or to regulate them. We're heading toward a situation where multiple nations and companies are racing to extract resources from the ocean floor with no clear rules, no enforcement mechanism, and trillions of dollars at stake. That's not a recipe for cooperation. That's a recipe for conflict. Problem number 2, actually getting the minerals out of the ocean. Deep-sea mining at 20,000 feet isn't like drilling for oil. The pressure is crushing. The environment is completely dark. The equipment has to operate autonomously for extended periods because human oversight is nearly impossible. The current approach involves 3 main technologies. First, remotely operated vehicles, ROVs, that can navigate the ocean floor, identify high-value nodules, and either scoop them up or use suction systems to collect them. Second, a riser system, essentially a giant pipe that transports the nodules from the ocean floor up to a surface vessel. This pipe has to handle enormous pressure differentials and potential blockages. Third, surface processing ships that separate the valuable minerals from the rock, disposing of the waste back into the ocean, or potentially processing it on board and taking only concentrated minerals back to land. China is ahead in all 3 technologies. They've been testing deep-sea mining equipment in the South China Sea and the Western Pacific for years. Their submersibles have made dozens of dives to extreme depths. They're treating this like the space race, a national priority with unlimited funding. The United States, meanwhile, is playing catch-up. DARPA, the Defense Advanced Projects Agency, has launched programs to develop autonomous underwater mining systems. The Navy is interested because rare earths are critical for military technology. But the U.S. still doesn't have a commercial-scale deep-sea mining operation. Japan is taking a different approach. They're focusing on seafloor massive sulfide deposits, hydrothermal vent systems closer to shore in shallower water within their exclusive economic zone. It's less ambitious than Mariana Trench mining, but also more feasible in the near term. Europe is hedging its bets, investing in both the technology and the regulatory framework, trying to shape international law in a way that favors European companies while preventing Chinese dominance. And then there are the environmental concerns. Problem number 3. We have no idea what deep-sea mining will do to ocean ecosystems. The deep ocean isn't a barren wasteland. It's full of life. Weird alien life that we're only beginning to understand. Bioluminescent fish, giant tube worms, microorganisms that might hold the key to new medicines or biotechnologies. And polymetallic nodules aren't just rocks, they're habitats. Creatures attached to them, they provide structure in an otherwise flat, muddy environment. If you scrape millions of tons of nodules off the ocean floor, you're destroying those habitats. You're kicking up sediment plumes that could smother marine life hundreds of miles away. You're introducing noise and light pollution into an environment that's been dark and silent for millions of years. Scientists are sounding the alarm. Over 600 marine biologists signed a letter calling for a moratorium on deep-sea mining until we understand the impacts. Dozens of major companies, including Google, BMW, and Samsung, have pledged not to use deep-sea minerals until environmental safeguards are in place. But here's the problem. Geopolitics doesn't wait for environmental impact studies. If China starts mining the Mariana Trench, what's the US supposed to do? Sit back and let them monopolize yet another critical resource? Hope that environmental concerns will slow them down? This is the classic tragedy of the commons. Everyone would be better off if deep-sea mining proceeded slowly, carefully, with thorough environmental protections. But if one player defects and starts mining aggressively, everyone else has to follow or risk being left behind. And in a world where rare earths are essential for military technology, for the green energy transition, for economic competitiveness, no major power is going to voluntarily handicap themselves for the sake of tube worms and bioluminescent jellyfish. The ocean floor is about to become the next extractive frontier, whether we're ready or not. So what does this actually mean for global politics? First, expect a new scramble for ocean territory. We've already seen this play out in the South China Sea, where China has built artificial islands to extend its territorial claims. Now imagine that competition extending to the deep ocean floor. Nations are going to start claiming exclusive mining rights in international waters. They'll use creative interpretations of the law of the sea. They'll sponsor corporate proxies. They'll deploy military assets to protect mining operations. The US Navy is already talking about the need to patrol deep-sea mining sites. China is building a blue water navy specifically to project power far from its shores. This isn't theoretical, it's already happening. Second, rare earth supply chains are about to get even more complicated. Right now, even if you mine rare earths outside China, you still have to ship them to China for refining. China has spent decades building that infrastructure, and no one else is caught up. Deep-sea mining doesn't solve that problem, it just adds another layer. You mine the nodules from the ocean floor, transport them to a processing facility, probably in China, refine them, and then ship the finished products to manufacturers. Unless the West builds its own refining capacity, which the US and Europe are now desperately trying to do, but that takes years and billions of dollars. Third, this will accelerate the militarization of the ocean. Deep-sea mining infrastructure, the ROVs, the surface vessels, the processing facilities, are all vulnerable to sabotage or seizure. Protecting them requires military presence. We're going to see more submarine activity, more surface vessel confrontations, more incidents where Chinese and American ships operate in close proximity in disputed or ambiguous waters. And finally, environmental disasters are probably inevitable. At some point, something is going to go catastrophically wrong. A riser pipe will rupture, spilling nodules and sediment across hundreds of square miles. A processing ship will sink, dumping toxic materials. An ROV will malfunction and destroy a critical deep-sea ecosystem. And when that happens, there will be no clear liability framework, no way to assign responsibility, no mechanism for compensation or cleanup. The ocean floor is about to become the Wild West, and we're all going to live with the consequences. So, where does this go? Best case scenario, the International Seabed Authority gets its act together. Nations agree on clear regulations, environmental protections, and benefit-sharing mechanisms. Deep-sea mining proceeds slowly and carefully with genuine international cooperation. That's not going to happen. More likely scenario, China begins commercial deep-sea mining within the next 3 to 5 years. The US and its allies scramble to catch up, ignoring or working around international regulations. Environmental concerns are acknowledged but ultimately ignored. The ocean floor becomes another arena for great power competition. And the Mariana Trench, the deepest, most remote place on Earth, becomes a symbol of the new geopolitical reality. There is nowhere left that isn't contested. No frontier that isn't being claimed, no resource that isn't being fought over. We mapped the ocean floor thinking we were exploring for knowledge. Turns out we were prospecting for the next Cold War. The discovery in the Mariana Trench isn't just about rare earth elements. It's about who controls the resources that will define the 21st century. It's about whether international law can govern the ungovernable, and it's about whether humanity can explore new frontiers without destroying them. The answer to that last question? History suggests no. But we're about to find out. If you want to understand the forces reshaping our oceans and our world, subscribe to Ocean Bingo, because the next war won't be fought on land. It'll be fought 7 miles down, in the dark, where no one can see what we're destroying. And remember to learn the ocean, love the ocean, protect the ocean.